Isn't it delightful to watch a tug-of-war match, especially when the teams are evenly poised? Well, in our case, the teams seem far too evenly matched. So what happens? Nothing moves. And in order for anything to move, I need to go and side up with one of the teams. Let me do that with the black team. Like this. Yeah. All right. So what happened? The balance did tilt in the favor of the black team. How did that work? What was the nature of forces before and after I joined the black team? We will figure out the physics behind tug-of-war and much more back at the studio. Hello, I am Charlene, and with me, you will learn the fundas behind physics and the tricks behind scoring those crucial marks. So, how do you think my tug-of-war match went in the morning? Interesting, wasn't it? But I was so tired after it. After all, I applied all my force to make the black team win. Force. Does that sound familiar to you? If not, then in next half an hour it will be. In today's episode, we will talk about the definition of force and the nature of some common forces. We will also discuss the differences between balanced and unbalanced forces. And to top it all, we will learn how to crack those exams in our last segment, Exam Decoded. But before we get started with force, there's something simple yet very interesting that you need to know, and that is motion. We see motion everywhere. My hands are in motion as I talk. Cars on the road are in motion. Aircrafts in the sky are in motion. And yes, the very earth itself is in motion. But what exactly is motion? Well, any object is said to be in motion when its position changes continuously with respect to a reference point. Have we got that one? Okay, great. So now this part is important for you to understand. The natural state of any body is to be at rest or stationary, much like me on a Sunday. So, how do bodies come into motion? Well, to put a stationary body into motion, we need to apply some effort or some force on it. In its most basic form, force is defined as a push or a pull. So if I were to define force, I would say the push and pull that is applied by an external agency so as to move the body out of its natural state of rest is called force. Well, here's an interesting query posted on our website by one of our young viewers. He wants to know if applying force on an object can cause any other effect other than setting it in motion. And before I answer this one, you tell me something. Do you think force is required only to put a body or an object into motion? Of course, the answer is no. Did you see what just happened? This ball was thrown at me. It was in motion. I caught it. I arrested its motion. But in order to stop it, I had to apply some force on it also. So force helped me stop motion as well. So then, force can make a stationary body move and can make a body in motion come to a stop. But that's not all. Let's tweak it up a notch further. Watch this. What did I do? The ball had motion and I changed the direction of the motion by the use of this bat. That's the third thing which force can do. It can change the direction of motion. And now for the last property. Since I can't hit the ball as hard as Dhoni or Sehwag, let me show you this phenomena in what we call extreme slow motion. Watch this. Now this is what actually happens when the bat hits the ball. It actually, for a fraction of a second, changes the shape of the ball like this, from a sphere into an egg shape. So, that's the other thing which force can do. Change the shape of objects, like this. Now let's try and understand what force is in a little more detail. Force is a physical quantity, which means, like all other physical quantities, it can be measured. The question is whether force is a scalar or a vector quantity. To answer that, let's go back to my famous tug-of-war victory this morning. In order to break the stalemate in the match, I joined Team Black and we won. Not only was I applying force, I was applying it in a specific direction. What would have happened if I had joined Team White instead? I would have reversed the direction of the force I was applying and Team White would have won. So we see that it is not only the amount of force, what we call as magnitude, but also the direction in which the force was applied that is very significant. Hence, direction is always associated with force to completely describe its interpretation. And I'm sure you're already aware that any quantity with both direction and magnitude is a vector quantity. So we can safely conclude force is a vector quantity. You can keep refining your problem-solving skills by visiting our website, topperlearning.com. Well, it's time to take a short break now, but before that, think about this one. Which of the following are vector quantities? Number 1, density. Number 2, mass. Number 3, force. Or number 4, velocity. Catch me on the other side of the break for the answer to this one. In the meanwhile, keep watching.